Welcome to Adu Globe. Discover new ideas, learn exciting things, and be amazed every day. In movies, explosions in space are often loud and dramatic, but in real life, space is absolutely silent. That's because sound is not like light. Light can travel through the vacuum of space, but sound needs a medium, like air, water, or solid material, to carry its vibrations. On Earth, when you speak, your vocal cords create vibrations in the air molecules, which pass the sound to someone's ears. In space, there are no air molecules, no water, no solid walls, nothing to vibrate. So even if a star exploded right next to you, ignoring the part where you'd instantly vaporize, you wouldn't hear a thing. Astronauts can only talk to each other in space using radios, which send their voices as radio waves instead of sound waves. The quiet of space isn't just peaceful, it's a reminder that our planet's thin layer of air is what makes every laugh, song, and conversation possible. Most people think space rocks only fall when we see a shooting star, but that's just the big stuff. The truth is, our planet is constantly collecting material from space, tiny particles called micrometeoroids. Every single day, around 100 tons of this cosmic dust enters Earth's atmosphere. These particles are usually smaller than a grain of sand, but they travel incredibly fast, tens of thousands of miles per hour. As they hit our atmosphere, most burn up completely, creating faint streaks of light too small to notice. But some survive the fiery entry and slowly settle on the ground, mixed in with ordinary dust. That means, without realizing it, you may already have tiny pieces of space dust on your car, in your backyard, or even on your rooftop. Scientists collect these particles from remote areas, like Antarctica, to study what our solar system was like billions of years ago. When Apollo astronauts walked on the moon over 50 years ago, they left behind more than memories. They left footprints, rover tracks, and even equipment. And here's the amazing part. Those marks are still there today, perfectly preserved. Why? The moon has no atmosphere like Earth's. That means no wind to blow the dust away, no rain to wash it off, and no rivers to erode the surface. The moon is a still, silent world where time moves differently for the landscape. Even tiny particles from space, micrometeorites, do strike the surface, but they are so rare that it could take millions of years to erase a footprint. Scientists believe the Apollo tracks might remain visible for up to 100 million years. So if you could visit the moon today, you'd see the exact steps Neil Armstrong took in 1969, frozen in time, a silent monument to humanity's first steps beyond Earth. On Earth, when you want to join two pieces of metal, you usually need heat, tools, or welding equipment. But in the vacuum of space, there's a strange phenomenon called cold welding. In space, there's no air or moisture to create a thin layer of oxidation on the surface of metals. That oxide layer is what normally keeps two clean pieces of metal from bonding. But without it, if two perfectly clean metal surfaces touch, their atoms don't. No, they're separate pieces. They treat each other like one single piece of metal and fuse together instantly. This effect doesn't happen often with large objects in space because most metals get coated with dust, oxidation, or protective layers. But in the early days of space exploration, engineers had to be careful. Unprotected metal tools or parts could accidentally stick together forever. Cold welding is one more reminder that space plays by very different rules than Earth. It sounds unbelievable, but it's true. Astronauts really do get a little taller while living in space. In the weightlessness of microgravity, the spine isn't pulled down by Earth's gravity, so the spaces between the vertebrae gently expand. This can make astronauts grow up to 2 to 5 centimeters taller. The effect happens within just a few days in orbit. Without gravity compressing their spine, their posture naturally straightens and their body stretches slightly. But there's a catch. This height boost is temporary. Once astronauts return to Earth, gravity starts pulling everything back to normal, and they usually shrink back to their original height within a few weeks. Scientists study this change closely because it can cause back pain for astronauts, and understanding it helps improve life in long-term space missions. So yes, space can literally make you stand taller, at least for a little while. Venus is one of the strangest planets in our solar system, and here's a fact that surprises almost everyone. One single day on Venus is longer than its entire year. How is that possible? Venus spins on its axis incredibly slowly. It takes about 243 Earth days for the planet to complete just one full rotation. But at the same time, it orbits the Sun much faster, finishing a full trip around the Sun in only 225 Earth days. That means by the time Venus has one day, it has already completed a year. And there's more. Venus rotates in the opposite direction of most planets, so if you could stand on its surface, you would see the Sun rise in the west and set in the east. With scorching surface temperatures hot enough to melt lead and thick clouds trapping heat, a day on Venus wouldn't just feel long, it would feel like forever. Earth has a powerful but invisible force field called the magnetosphere, created by the movement of molten iron deep inside its core. This magnetic shield stretches far into space and acts like our planet's personal bodyguard. Its main job: protecting us from dangerous solar radiation and charged particles constantly streaming from the Sun in the solar wind. Without it, these particles could strip away our atmosphere, fry electronics, and make life on Earth nearly impossible. Sometimes, when the solar wind hits the magnetosphere, it sends particles toward the poles, where they collide with our atmosphere and create the breathtaking northern and southern lights. Scientists believe Earth's magnetosphere is one reason our planet can support life, unlike Mars, which lost most of its magnetic field billions of years ago, and with it, much of its atmosphere. This invisible shield may be silent, but it's always on duty. Every year, the Moon drifts about 3.8 centimeters farther away from Earth. This happens because of the gravitational dance between our planet and its only natural satellite. The Moon's gravity creates tides in Earth's oceans. As Earth rotates, these tidal bulges pull slightly ahead of the Moon, transferring energy to it. This extra energy pushes the Moon into a higher orbit, very slowly increasing the distance between us. Scientists discovered this by placing special reflectors on the Moon during the Apollo missions. By bouncing laser beams off them, they can measure the distance to within a few millimeters. While 3.8 centimeters a year doesn't sound like much, over millions of years it adds up. In the far future, this drift will make total solar eclipses impossible, as the Moon will appear too small in the sky to fully cover the Sun. For now, our Moon is still close enough to light our nights and inspire our imaginations. Crying in space isn't like crying on Earth. Here at home, gravity pulls tears down your face, but in the microgravity of space, there's nothing to pull them away. Instead, tears just form little floating blobs on your eyes. Astronaut Chris Hadfield once explained that when you cry in space, the tears stick together, making a watery layer that can blur your vision and even sting if they mix with sweat. To get rid of them, astronauts usually have to wipe them away with a tissue or let them drift off in small floating drops. The reason this happens is simple physics. Without gravity, liquid doesn't know which way is down, so it stays in place, clinging to surfaces by surface tension. It's a small but surprising reminder that even the most ordinary human experiences, like shedding a tear, can become strange and fascinating when you leave Earth. Space is not just silent and empty, it's also a place of extreme temperature swings. Because there's no atmosphere to trap or spread heat, the side of an object facing the Sun can get incredibly hot, while the side facing away can be freezing cold. For example, on the Moon, daytime temperatures can reach about plus 120 degrees Celsius, 248 degrees Fahrenheit, hot enough to boil water, while nighttime temperatures can drop to minus 100 degrees Celsius, minus 148 degrees Fahrenheit, or lower, cold enough to freeze metal. Astronauts and spacecraft must be specially designed to survive both extremes, using insulation, reflective materials, and heaters. Even the International Space Station faces these temperature changes every 90 minutes as it orbits Earth, moving from sunlight to darkness. These wild swings remind us how unique Earth's atmosphere is. It acts like a natural blanket, keeping temperatures stable enough for life to exist. Without it, Earth would be just as harsh as space.